Okay, the next chapter is rational expressions. And it follows the chapter on factoring because actually we're going to do a lot of factoring. It's going to help us simplify these situations. So if I see this, I might think, I wonder what would happen if I factor the bottom, the denominator. Let's see. This is one of those that you might be able to see. If I have minus 7 and positive 1, that will give me the minus 7 and the minus 6. And oftentimes it works where there's something for us to cancel out. So this actually does simplify, right? Because I've got that quantity and this quantity to 1 over x minus 7. So that simplifies down nicely. So they're called rational expressions because they are a ratio of expressions. Now, let me get both of these on the same screen. Alright, now here's the domain issue. Once you've factored it, so before I cross out all that stuff, and you might think, well, why not focus on this? And say, right, I don't want to divide by 0. That's a no-no. Don't do that. Alright, so what would make the bottom 0? Well, when x equals 7. Alright, so our domain is x can be all real numbers such that it is not 7. So as long as it's not 7. Okay, so why don't we look at that alone? We actually have to look at this. Why? Well, it does simplify down to this, but we are looking at this expression. I know, it's a little interesting. It simplifies down to this, except it also had this in it. And so we have to consider the original expression. Right, because the original expression, no matter what it simplifies down to, this has to exist. It has to be defined at all points, or we have to exclude the points that do not work. And I'll go back and we'll take a closer, well, we'll see it. I'll show you why it does not work. Okay, so when is the bottom 0? Well, if x is 7, then you have 0 times 8, which is 0. Or, if x is negative 1, that would make that 0. This would be negative 8, and the product would be 0. So actually our domain here is x such that x is not equal to negative 1 or 7. So why does negative 1 matter? Even though it works out in the simplified version, this is the expression that we were given. And in this case, if I were to plug in negative 1, I would have 0 on the top, which, by the way, is fine. It's equal to 0, not a problem. But in the bottom, I have negative 1 squared, minus 6 times negative 1, minus 7, which is 1 plus 6 minus 7, which is 0. So I actually have 0 over 0. And this does not exist if x is negative 1. Alright, so because that does not exist, I need to say over here, going back to simplifying this rational expression, it is equal to this as long as x is not negative 1 or 7. Okay, provided that.